Warmly welcome everyone to this Innovation Summit on waste identification. There's a lot of people waiting. Elida is helping me with that. Welcome. There's so many people dropping in. We've chosen to do this meeting as a simple Microsoft Teams meeting. Since the pandemic broke out, we have built up a really nice studio at our office, but since the last restrictions, we are all working from home. And so this is a little of an experiment, because what I believe is that this simple setting will trigger even more discussions and collaboration. But we need to collaborate in more than one way, not only within waste identification, but also with this meeting. And therefore, I will now go through some really relevant meeting rules that you have to help me with. So if you have them on my next slide. So please, if you're not presenting, mute your microphone. If you have any comments or questions, first of all, we will wait with them until after each presentation. So there's space after each presentation for questions. Meanwhile, you can either type in your question or comment in the chat box connected to this meeting, or you can use the raise your hand function. I've showed you the symbol for those of you who are not familiar with Microsoft Teams. And it's also nice if you present yourself with name and organization belonging. I will also say that this session will be recorded and later on posted or at our webpage, materialbusinesscenter.com. So please, if you have an issue with that, contact me or my colleague, Elida, and we will blur your existence of this. Myself, and my colleague Erik will act as moderator for today's session. I have also with me today my colleagues Jonas Andersson and Elida Simic, who will help me out with assisting this meeting. And also I have Svedin, who is not only, he's representing Mobile Heights, and he's also co-host of this event. And he's also co-host of one of the test beds you will hear later on. Co-hosting it together with us, Innovation Skåne, Teknik, Norrvidinge, and Microsoft. But Ola, please present Mobile Heights, and I will stop sharing now.
Okay, thank you, Carl, for a great introduction. So I just wanted to take the opportunity to talk a little bit about what we have done together with Material Business Center the last couple of years and what we're doing right now. So in fact, Mobile Heights and Innovation Skåne, which, as you know, is the host organization for Material Business Center, have been working together since 2016 in organizing various events and organizing various activities such as workshops. And it's the area in which digitalization and material science, where they meet, that is where we can share knowledge and share experience and reach the respective areas. So for those of you who don't really know what is mobile heights, I will show you the presentation. I hope that is visible now. Is that? Can you see the Mobile Heights logo now?
Yes.
Good. So a few words about Mobile Heights. It was founded in 2009 by Sony Ericsson Telia Company and the universities of Lund and Malmö, as well as Region Skåne. And we are a non-profit ICT cluster organization and networking community. And one of the key areas that application areas that we are addressing is future digital manufacturing and materials. So that is kind of the area that I was talking about, that where we work together with Materials Business Center. Today we have 125 members, mostly based in Skåne, but also a few members outside of the region. And this is what I call the logo soup. It should be 125 logos here. And as you can see, it's large companies as well as medium-sized companies, small companies, startups, as well as a host of municipalities and innovation system actors. And we are doing a lot together with our members, and also, in fact, we involve other parts of the cluster, not formally members of Mobile Heights. You don't have to be a member of Mobile Heights to interact and work with Mobile Heights. This is a long list of projects that we're doing right now. And today, of course, we will hear a little bit about, or a lot about, waste identification testbed, in fact. Another large initiative that we are involved in is AI Sweden. And you will hear from Erik Wilson of Mobile Heights, who is working full-time with this assignment, which is all about AI and spreading the word and spreading the knowledge about AI in Sweden. So Carl, I think I'll leave it there. Thank you. I'm looking forward to hear this very interesting seminar today.
Yes, thank you, Ola, and for the nice words. And then if you stop sharing, then I will share, go back to my presentation. I think it's this one. And I'll do the same thing. I will present just a few words where I come from. Me and Erik, Elida and Jonas, we work at Innovation Skåne. We have a vision that I've just recently translated to English, enforcing innovations from Skåne to make a sustainable impact globally. And that is really aligned with today's topic. We work with creating or stimulating new jobs to occur in Skåne, and also to improve the healthcare service provided by Region Skåne. We work within 5 innovation areas at the moment: mobility, health tech, smart human-centric light, food tech, and materials. And within materials, we run several projects. One is the Testbed that you will hear about, and another one is the Material Business Center that is host of today's event. At Materials Business Center, I hope, yeah, okay, yeah. So we wish to make the best use ever of these 2 fantastic investments, ESS and Max 4, that you all heard of, and to make some form of return of these investments. And we believe in, by creating the best environment around them, we will get that return. And this environmental cake has the ingredients that are listed below or in the middle. So we are building a startup community. That's what we focus, I would say, most of our time on our startups. At the moment, there's 36 of them, and we help them in whatever legal way we can. Business advisory, we have breakfasts on relevant topics for them where they can meet and also discuss common issues and learn from each other. Another important ingredient in this environment is because, yeah, and I should say that this environment is actually becoming even more relevant during this pandemic, because the pandemic has forced the facilities to digitalize, so samples are being sent there and the results are being sent back digitally, resulting in not that many visits. And of course, we want people to want to visit and want to stay and stay another day, or why not stay to start your company? Because for science to make an impact in the society, it's in many ways a commercialization is needed. Anyhow, the second ingredient in this environment are the CROs, the mediator, the contract research organization. I saw that just Roberto Ortiz from CR Competence logged on. He is representing one of these CROs. So we have some funding for contracting these mediators in favor or by solving the needs of our startups. So we make double use of this funding. Another important part in the cake is the established companies. Not only that they can show the actual demands on the market and then making the other actors in this environment to focus on actual market needs. But we've also learned that the established companies, and I should say, yeah, also the public sector is one of them. But the established companies plays a role when it comes to helping startups that are in the phase of internationalizing. Because by collaborating with already internationalized companies, they can piggyback and then reach more markets faster. And by that also creating more jobs in Skåne, where they have their head offices. And of course, academia and institutes are given important ingredient, and to make all of these parts collaborate. And one way of getting this collaboration is by our innovation summits, such as this one. And I'm really happy that we are so many today. 48 logged on, no, more than that. Yeah, add another 1, 2, 3, 4, 5, 6, 7. Yeah, so 56 at the moment. I saw there were over 85 registered. And it's not only the number, it's a really broad range of attenders today. So I've made a picture just to show you, can you see it? Just to show you the names, it's impressive. And yeah, so what I wish is that let go of the US election and let us, for the next 1.5 or 2 hours, focus all our collective competence and experience on today's topic, waste identification. Because it's really, as Ola said, in the crossroads of all these industries, areas of expertise and so on, that's where we find new ideas, thoughts, collaborations, or even businesses. And that's the whole purpose with today's meeting. So please be active. Ask questions, and if you would like to either engage in anything that you hear of today, or if you would like to get in contact with some other participants, don't hesitate to contact me or my colleagues afterwards, and I will help you with that. But with these words, I would like to hand colleague Erik, and he will give you both an overview of today's topic and also a first introduction to a newly launched Testbed. So here you are, Erik.
Thank you. So I just want to set the scene here and talk about why recycling is important, why we should be excited about it, and why the timing is really good and being interested in recycling right now. So this is where I start. For those of you who do not speak Swedish, this is an opinion piece 2 years ago in Sweden's largest newspaper. And it reads that Sweden loses out on 42 billion SEK each year due to insufficient recycling. Because that's basically the market for improving recycling. And we are, so if there is no money, it's hard just to say it's good for the environment. But here we have them working hand in hand, because at the same time as we would improve recycling, we would also save about 30% of the carbon dioxide that comes from this. And of course, all of this does not have to do with waste identification and sorting, but a lot of it has. Another part, I was really excited to see that there are some people from the design industry that have signed up for this event, because of course a lot of it is also designing to recycle. But I will go in more to part of these 42 billion we can approach with better sorting. So as Carl said before, we have mainly been supporting startups that are producing materials, but we are also interested in looking at recycling materials. And it's also because we're owned by the regional municipality that has a focus on creating a more circular economy. And also, as Carl was talking, I was saying about the digitalization and the intersection that happens now between industries. And just looking at who's attending here, there is a lot of different people from different backgrounds. And the final thing, why we are involved here, is that a test bed can be looked at as a shared solution to a shared problem. Everyone wants better sensors, and everyone wants these sensors to be operational and implemented, but it takes time. We are one of those organizations that can take one of those problems, turn it into a project, and help facilitate that cooperation through the whole value chain. I just want to first briefly touch on the fact of circular economy. And basically what it means is just that one industry's waste is another industry's resources. Because in the end, waste, there is no such thing as waste. It's all material, but it's in the wrong form or just in the wrong place. And I just wanted to show it here with plastics. Carl, I think you had something about packaging.
Yeah, I spoke the other day with Marie Malmberg Lavsen, who is heading the packaging cluster Packbridge. So she's representing the packaging industry. And what she said was that from January this year, the EU Commission no longer accepts incineration as recycling. That means that previously packages has been marked as recycled if they were recycled as heat. And that is, of course, well, it's some form of recycling, but not good enough in my opinion. So this is very good, but it's also meaning that the packaging industry and all those industries that uses packages, food industry, for example, they can no longer say that they have fully recyclable products unless they can prove that there is a way of recycling them. So they are really wanting to reach out to the recycling industry to say, hey, help us, we want our packages to be recycled. Yeah, that's it.
Yeah, well, good. So I looked at the numbers. I think it's about 16% of all plastic in Sweden that is recycled. So that's, of course, a very low number. And then I also chose plastic because everyone's talking about plastic. But now taking on the perspective of one industry's waste being the resource for another waste. So talking about food packaging, you need to use virgin material. You cannot use recycled. But as you can see from the top row here, packaging is the biggest market for plastic in the EU, and that's where most of the waste come from. But now with our new perspective, that is not waste. That is a resource for another industry. So if we move down to the third row, we have automotive. I mean, the bubbles here are smaller. It's a smaller market for plastic. But at the same time as legislation now says that we need to recycle more plastic, automotive companies, they want more of their plastic to be recycled. So we are creating a market there. But then these bubbles need to be connected to each other. So as you might be able to see from the first column, there is way more polyethylene used in packaging than in other markets. And in for some of the other plastics, you would have the opposite situation. So I'm just showing you this picture that, for example, maybe more packaging should be in PP, that's polypropylene, just because that's where the market demand outside of packaging is larger than the creation of plastic waste from the packaging industry will be. So this is just looking at a systemic level on a whole industry, what could circular economy be? But as I said, it's only 16% today in Sweden that gets recycled. So that needs to be improved. I will also just briefly talk about the region and why there is a focus on circular economy. So 10 years ago, the regional council decided that the operations of the municipality should be climate neutral this year. And they've almost done it. So the public transport is 100% fossil free and has been for almost 2 years. The hospitals, the facilities, it's 100% fossil free. And this has been achieved by and without any cost increase. As I was talking about before, when we can do something for the environment and save money at the same time, that's when things happen. In contrast, and this is why recycling is important for the region, the third biggest post of greenhouse gases has been from the waste from the hospitals. It was 536 kilograms of waste per hour, every hour throughout the year before COVID. And now it's even more. And of course, most of it is plastic. To become climate neutral, then the region would need to, today, change into bio-based plastics, but that's more expensive. And I'm hesitant of if I want to pay more taxes for the hospitals to use bioplastic. So that leaves recycling. But then again, as I said before, with COVID, nobody wants to manually go through the hospital waste to find the bits and pieces of valuable plastic. So there is a need for automated sorting. And this is my grand vision of why we want to see smaller, faster recycling robots. So the driving forces that we see, why why this is an interesting area at the moment. First off, we have the environmental goals, and not only as goals, but also as legislation, that we will increase the amounts we need to, and therefore we need better sensors, we need better sorting. And then there is still a lot of manual sorting, even in Sweden. And then if you think around the world, it's even more. But of course, we are seeing now that automation is happening, and that of course leads to digitalization. And the initial investment for automizing is of course substantial, but once you've done it, the cost of adding one more sensor to improve your sorting, or to include extra sensors for new materials, then it's pretty low cost. And of course, as with everything with digitalization, the pace of innovation will increase. And of course, this also means that there will be new players coming into the market. I guess a couple of years ago, not many people in recycling were talking about machine learning, but they're interested now. And of course, all this will lead to better and faster and cheaper identification and sorting. And looking even further into the future, with automized identification and sorting, and our new perspective there of waste being a resource, what you are collecting is basically market information. You know what you're sorting, you know the value. Well, if you look it up, you will know the value of everything, and you could basically create an automated spot market for materials as in real time when you're actually sorting it. But it has been hard to automate identification. I mean, digitalization went through the easiest markets first, media, banking. This is actually pretty hard because it's the material might be dirty, it might be different colors, it might be different shapes. And first you need to identify, and then you need to sort, and it's really difficult. But on top of that, there are some additional issues that we are trying to address with our testbed. There is a lack of standards for sensors, both like on the hardware side, you connect it with a USB or with some other cable, but also on the software side, that there is no like Android for identification sensors. And so that's one part of it, that you need to hardwire every sensor that you might want to test. And that, of course, slows things down. And the other thing is, if you're like a researcher and you're developing a new sensor, you need access to waste material because you need to test your sensor. And you can only get that if you are a registered waste management company. So, excuse me. So we decided that we're going to start a test bed. And you see here, the partners is Teknik. Fredrik will talk in a short bit. Svedin, that is a waste management company. Mobile Heights, and Innovation Skåne. And we're doing this project with the support of Microsoft. So what we're looking at is a shared solution to a shared problem. It's the problem of identification, and that more sensor needs to come out on the market. That's for the whole value chain. And what we want to do is facilitate faster implementation of sensors on the market, meaning they need to be almost ready for the market for us to be able to implement them. And we've created a neutral test bed, so a sensor company can come test their sensor. It's easy to connect. You get your data with you when you go, and a waste management company could evaluate and compare different sensors before implementing. So if you are a sensor company, or if you have some very specific type of material that you want to test, please contact us. Because what we are building is an easy way to install sensors and an easy way to download data and its neutrals. And we're also on site. So we have a large variety of materials to test. And of course, Norrköping being a waste management company, they have all the certifications they need. And it's a real life environment with all like the temperature, the dirts, everything that you might encounter. Yeah. So I will conclude there. And you're very welcome to contact me for more information on the test bed. And I know Fredrik will, in a short while, go more into what the test bed is about.
Great, Erik, thank you. I will start to say that I love what's happening in the chat window. So far, I can't see any hands or questions to Erik from the audience. Do we have any as such? Otherwise, I will give you a question, Erik. So what's your wish that the outcome of this event, this 2-hour session, will be?
Well, a lot of questions from, well, I mean, connections, people interested in testing sensors, that would be first thing. But other things that could come would be material producing companies wanting to test a specific property. That could, of course, also be something. And yeah.
Good, great. Okay, so here we have a question from Tatiana. Could you please give an example of projects the testbed will run?
Yeah. Okay, so any specific waste streams? So I will start there. No, I guess all waste streams are interesting. I mean, it of course depends on what sensors will we be talking about and what material. There is a match, of course, so there will be some kind of a sweet spot. And well, I don't know. I mean, the best case scenario would be, I guess, with better ways to identify metals or black plastics. I mean, the holy grails. But yeah, so give an example of projects. So I'm not quite, I understand, but basically installing a sensor, running through whatever waste stream we're looking for, and then looking how well the different sensors will be able to identify.
Yeah, and I could add to that I don't know if they have logged on yet, but Bintel, for example, who are using the technique from Acuneer, for example, if they would install their radar sensor to identify objects, that would be really interesting, for example. But you will hear more about, I think your questions will be answered later on in the later presentations. And so if you have more questions to Erik, there will be a discussion after all the presentations, and we will move on. Now we will hear from a guy who previously been an entrepreneur himself through his company BioLife, but now employed by Mobile Heights and the AI of Sweden. So Erik, are you with us?
I'm with you.
Okay. The show is yours. And
thank you.
Do you have anything to? Yeah, you're familiar with Teams. So if you have anything to present it.
Thank you. Let's see if it works. So I was quickly invited to present the project I'm involved with now, called AI Sweden. And thank you, Erik, for your great vision of the waste spot market in real time. That was something that got me excited too. So AI Sweden is a quite recent initiative, started in the beginning of last year, 2019. And it's, you can say, a governmental initiative to make Sweden take a better position on the global AI market, to make sure that our organizations and public organizations work with applied AI. And don't get spooked by the broad term AI. It's usually what you think it is. In the end, it's just math and statistics. But here with you can say a digital layer to make sure that it's getting used and applied, and that we can work with it in real scenarios. So AI Sweden, you can say, is a national center for applied AI, and we act as a neutral, non-profit and broadly funded organization. So we're funded by Vinnova, but also by membership fees from partners and regions. And in a nutshell, we're here to help actors like yourself. And the reason is that the government saw that Sweden is lacking behind in the AI race, you can say. So they initiated us to help organizations take a better position. And how we do that is by connecting to the current innovation and cluster system in Sweden. So that you met my colleague Ola before. So here in the south, we originated from Mobile Heights. But what I'm also saying is that we are a national initiative. So me and my colleague Malm, we work here in the region to see what's happening here in the regional presence and taking good initiatives like this waste identification testbed and see if we can bring it up on a national level and vice versa. Doing cross-pollination, you could say. And we work with partners here. Many of them you recognize here in the south, for instance, region Skåne, the large municipalities as Helsingborg, Malm and Lund, and also the universities. And the offering we have for partners is, as our offering slide, so we engage with them in various AI activities. So we're here to try to solve the big questions. Me as a project manager, I usually engage with projects where with problems that many actors are facing. But we're also organizing hackathons, creating networking events. We have a legal group to investigate data sharing questions and GDPR issues that are issues all partners are facing. So example of projects we are running, for instance, one is Swedish Language Data Lab. There's a AI technology called NLP, Natural Language Processing, which is a technology that interprets text. And these models are usually coming from English. And this is, for instance, this project is an initiative to make sure that we can actually use Swedish instead, since it's our main spoken language and used in governmental institutes. Another one is, for instance, working with the Swedish Space Data Lab. Since ESA are having a couple of satellites running around Europe or circling the globe, so here we make sure that space data or satellite images are more easily accessible. Another pie chart of our offering is what's called a data factor, and I think this is interesting for you. So for instance, the presenter after me, Teknik, to be able to do what they have done is then you need to create or train models using, for instance, technologies called neural networks and image recognition. And for that, you need compute power. So here at AI Sweden, we have at our disposal, you can say a supercomputer. It's an NVIDIA A100, which consists of 8 GPUs for you who know what it is. But it basically means that we have a test bed for partners to discover what hardware do you need to work with AI, because it's still such a new field. So some of you might have seen the cloud providers, Amazon, Google, and Microsoft, who are offering compute on a tap, you can say. But for other actors as big industry partners like AstraZeneca, Volvo Group, and so on, it's more reasonable for them to buy their own hardware. So here we're providing a test bed for you to play with your data, and it all comes down to the importance of your data. What data do you have and what do you want to do with it? And that then the next question is what compute and what hardware do you need to train your models? So at Sweden, we have this at your disposal as a test bed, and we also have, for instance, legal experts connected to the questions regarding data sharing. And since we're working with a lot of the public sector, all those organizations are having issues with GDPR. In Sweden, it's a common challenge that we cannot collaborate with data. So I hope that since you're working with waste data, it's free from personal information, so it's much more easy to share. But this is some of our offering, and if you have any more questions, you can reach out to me and my colleague Malm here in the south. Thank you.
Well, thank you, Erik. And yeah, so I'm just looking here. I don't think, is there any questions for Erik?
Yes.
Yes, from Fredrik. There you are.
You said that you could test and basically check what kind of hardware is needed for certain networks, but do you also give recommendations on what kind of networks to use in detail?
I think that depends on from case to case. So we have some team of 6 people who have been working with this for a while, and if we cannot answer the question, we contact our partners who usually have this expertise. So we are working with partners as like hardware providers themselves, as HPE and other actors. So I can usually answer the questions.
Are you also providing some kind of labeling tools, or does the data has to be classified, or how do you go about the big data set that is that doesn't have a gold standard? How do you do that?
So in the data factory, we have donated data. And I think then it comes down, the ideal case is that it has the gold standard, that it's classified and is labeled. So far we have only received labeled data, and that's easy for anyone to work with, but I'm sure we can point out tools and ways forward to label it.
But it's not part of your offering to go about a large data set that is not at all labeled.
No, that's not something we offer. So what data are you sitting on?
Yeah, we're sitting on this waste data, and some is labeled, some is unlabeled, and for instance, if you have an incoming waste stream, there could be a change in this incoming waste stream, and you would like to see whether the incoming waste stream is changing at least somewhat, and saying, hey, we need there should be another class here. We should try to do some kind of auto labeling to take it to the next level and divide it directly into subclasses or something like that.
That's a very good question, an interesting use case, I guess, that we see more of in this testbed. So those tools is nothing we're providing. I'm sure we can, like, so this use case is, I guess, is that we then put you in connection with others who have been in this situation before. So some of our data is, for instance, coming from SenSoRe with the Volvo cars, where they have road data from almost entire Sweden, where I'm not sure how they have gone about to label their data. Usually big tech organizations are using manpower in India to label their data, for instance. Yeah.
But it sounds very much like Fredrik and Erik should have a cup of coffee.
I thought the same. Feel free to send me an email and we can have a discussion regarding this. It's very interesting.
I like that.
Good. Any more questions for Erik? Because unfortunately, Erik will have to leave. But of course, you can find his contact data or contact us if you have more questions. But if you have specific questions now for Erik, please ask them. Otherwise, we will move forward in the schedule. Okay. Yep. So very fitting now that I am going to introduce Fredrik Brandt, the man you've been hearing with the difficult questions. Fredrik is the product manager at Teknik. So he builds sorting robots. And the name of your presentation would be automated waste sorting. So the floor is yours, Fredrik.
Okay, thank you. Let's see here. Okay, so the OP Group develops and manufactures recycling robots, but we also work in various industrial automation projects, which means that we go to industries and help them to automate their production. OP as a group has been working more than 30 years in practical recycling with machines and handling of waste. And in 2019, which we are very proud of, the industry voted us as Innovator of the Year for our sorting robot Selma. We are located in Tollarp in the eastern Skåne, and we are around 15 employees. Waste processing as such basically consists of a number of machines which handles the materials, and in the end you sort it, sometimes manually, like Erik said, and sometimes automatically. And this process should be more automated in the end. So in this picture, on the left, the waste comes in and it's handled by a huge material handler, which is the green machine. Then it goes through these machines, and this can vary quite a lot depending on the incoming material and the volume at the various sites. And these machines don't have to be at the same site. So this is just an example of how it can look like. But basically the material is shredded to get it into a uniform size and separate the material. This is the kind of placing of our sorting robots. So the shredded material is placed in a bunker and it goes via conveyor belts into the sorting robot. And in the containers below, you will end up with sorted material ready for recycling.
Sorry, Fredrik, can you just pause?
Yes.
So Jonas says that he cannot see your presentation. He can only see some text saying can't display content. Does anyone else have that problem? No. Okay, so it might only be. Yeah, it's only Jonas. I will email the presentation to Jonas and you can follow it from there.
Okay. So basically, why do you want to sort is the big question. And Erik has been touching on this. In the EU, there is 850 million tons of C&D, which is construction and demolition waste per year, and only 40% of this material is recycled. So the EU has a big initiative of reaching a higher recycling goal. The reason for this is to get a better use of resources and reduce the CO2. So we want to go from 40 to 90% recycling with automation. We can also work in various waste streams. We have been focusing on the C&D, which is the largest waste stream in the EU, but we can also work on industrial waste stream and plastic waste streams. And for people outside the recycling business, these waste streams are quite similar. So we have built a unit which is called SELMA, Select Material. And when you buy this unit, this is what you get on the picture here. It's a house weighing of 32 tons. But in this house, we control all conditions, and that is quite important to be able to measure accurately. So the air pressure we control the temperature, and then it's just to plug it in with electricity, network connection, and a little bit of ventilation, and you can start to recycle your material. The unit SELMA itself has 3 tasks to do. When material hits the conveyor belt, we want to locate the material, we want to classify the material, and we want to pick the material from the waste streams. So we have divided into these 3 groups of doing it. We work with the various data sensors, and we are, like Erik said, we are open to exploring new ways of finding materials and objects in the waste stream. As of today, we work with standard vision cameras, both to detect but also to classify data. We work with hyperspectral imaging, which is a kind of sensor of light spectroscopy. And we also have metal sensors to find metal. So how does it work? This is a drawing of the unit from above. So the waste comes from the left and it passes various sensors, hyperspectral vision, metal sensors. It goes to a computer and the computer locates how to pick the object that we have seen, but also to classify the object itself. And this is what it can look like from the vision data perspective. And as you can see in this image, it's not so easy to just pick it. You want to pick it, the object in the middle, close to the center point of the object, but that's not always possible. So we have to calculate a good picking position. Is it possible? Will it rotate? And so on and so on. And the robot should not crash into another object. That's also very important. So you have to calculate on a global level and also on a local level. And on the right, you can see yellow is okay gripping points, while red are forbidding gripping points. Vision data for classification is, like Erik said, it could be quite tricky, and it requires large data sets and quite heavy computer capacity to do this. And this is the type of images that we work with every day to classify the materials. But in the end, you need around 1 million images per class, very roughly. and it depends on the variation of each material. So wood has actually a very small variation, while plastic has a very, very big variation of the data. But with vision data, you can also identify what we call objects, which is not materials, but it could be like shoes, specialized coils, or any other object that we want to be able to recycle. So it's not only actually material recycling, it can also be objects that you can, which could be very interesting in the CO2 perspective. And how do we build this database? And Erik touched upon it a little bit, but each day we upload around 100,000 images just like this to our servers. And we can see directly what has gone well, what has gone wrong, and has there been any change due to maybe weather conditions, temperatures, and other things. These classifications can be very sensitive from time to time. Hyperspectral data. It works a little bit different, and I think that Sune will come into this more in detail. But basically, it doesn't need a big database. We have certain objects and fit a curve, or it's about curve fitting. So you send out light on the object, and the returned light is then measured. And it behaves basically in the same way for all materials. But this technology works very well in plastic, paper, and wood. But it has very big limitations as well. For instance, black material is very hard to identify with this technology due to the fact that it absorbs most of the light. Metal is impossible also because it reflects too much of the light. And as the number of classes you want to identify increase, it gets harder and harder, and it's a fact that you basically fight over the same frequencies. So the number of frequencies that you can use will always be the same. There is also some kind of limitations when you have wet material. It changes the returned light quite heavily, and you measure on the surface, and it means that if it's too dirty, too wet, it could be oily or something like that. There could be restraints as well. Okay. Do we have any other problems? I've just talked about problems basically, but we want to go ahead and sort more and more. And as we see it, there is no limitation of how much you can sort and how much you can go into details. And basically, we want to be able to sort metals into different alloys and different types. And then you have to use different kinds of technology, which we don't have in our system today. Also, subfractions, and Erik touched upon this as well. For instance, in plastics, you want to find different types of plastics. And this is also something that we want to look into much more in detail. It could be the same with wood, that you would like to sort it into fresh wood, wood that you can reuse in certain industries and so on, and that will increase the level of recyclability. Okay, last but not least, our test bed. At the Norrvidinge site in Halmstad, we have a working robot, which is also an open test bed. So what we have done basically is that we have modified the software so that anybody can come with a sensor and place it directly into the robot unit and record all data, not only from their own sensor, but also from our existing sensors. Because we see that one sensor will not identify a material. It's the combination of sensors that will identify materials that we have some kind of problems with. And a problem when you test sensors like this can basically be that it's very hard to find these large types of waste streams, but we have that in place in Halmstad. So the system is pre-configured for testing of sensors, and the material is in place. So basically you can come with your sensor, put it in our robot and go home the same day with a large amount of classified data. So in the end, I would like you all to join our mission to recycle more. Okay, thank you very much for your attention.
Thank you so much, Fredrik. Very interesting. We have 3 questions in the chat. Let's start with Pontus' question. Would you like to say it yourself, or maybe Fredrik, do you see the question? It's about
no.
Object size. How large are the objects coming on the conveyor belt?
Well, today the objects range from around 10 centimeters to 50 centimeters. And this is a trade-off. When you take it through the shredder, you want to achieve as big objects as possible, but homogeneous objects in terms of material. Because you don't want to sort materials that are combined, and in the construction and demolition waste streams there is a big likelihood of that the material objects, if you don't shred it, is of combined material. For instance, there is metal hanging onto to wood or plastic or something like that. Then it's not reasonable to sort it. So around 10 to 50, 60 centimeters. But we have no limitation, and we can change robots to bigger robots if there is another waste stream that can pick a heavier fraction.
And great. Melina wonders about the speed. How fast are the robots picking things, or tell us a bit about that.
The robots in combination, there are 6 robots in our standard unit, and we can do up to 10,000 picks per hour with all 6 robots. If the material flow is even and nice.
And could you say it in another SI unit, like seconds?
Well,
you have 2 seconds to pick an object, for example.
Yeah,
like that.
or closer to 1, I would say.
Yeah. And then Jakob wants you can classify different metals with your inductive sensor.
We can separate, which we have not investigated too much, between ferrous and non-ferrous. But with this kind of technology, it's not possible to go into different alloys like copper or iron or aluminum. But it's something that we are investigating, and there is we see a big demand of that from the industry itself. But on the previous slides that I had, there is technology which is maybe not commercially too available, like LIBS and XRF, which is laser and X-ray, that can do this.
And then we have a lot of questions. I like this. From Claes, what kind of AI solutions do you use?
Well, we use a CUDA-based TensorFlow from I think it's NVIDIA's implementation of this.
Good. And then Chandra Muli asks, have you performed any scenario analysis to identify what kind of incoming waste stream would have the best return on investment for the money invested in the sensors and robots? For example, what would be the break-even for municipal waste streams given the current commodity price? Long question.
Yeah, I'm not sure I fully understand it.
But maybe, yeah, and maybe Alfred from Norway could answer it, but I think it would be something with metals. That metals would give either just to sort metals, or if you could separate one metal from a metal stream, that would give the best return on investment. Is that a good answer?
Yes, that's correct. Of course, if you sort high value materials, that's the big difference in the investment, so to say. Yes.
And then we have another colleague present of mine, Lars Tilly. What are the most difficult type of materials to distinguish, and what type of sensors do you really miss?
Well, again, I think that we miss this kind of metal separation sensor. That is one of the holy grails, and very dark black material that absorbs a lot of light is quite tough. So I would say metals, we are missing that sensor. Black plastics is quite hard.
Good. Okay, we're running out of time, but I have a question myself too. Why don't you use magnet to separate ferrous metals from other?
Well, it is actually used, but not in the container itself. So if you look closer on the earlier slides, on the processing line, one of the machine is actually a magnet that picks heavy fraction metals. However, it should be used with care, because if you don't spread it, a lot of other materials can follow and so on. So in your question, it is used, but it should be used with care.
Great. Thank you so much, Fredrik. Very interesting. And I guess that both of us have had the next presenter as a tutor. I have at least. And
yes,
that is from atomic physics. He's now senior professor. He's former committee member of the Nobel Prize Committee in Physics. Sune, you are also Sune Svanberg. Are you with us?
I'm absolutely here. Yes.
Yeah, we are all glad to have you here. And by that, I will hand over the word to you.
Yes. Okay. Thank you very much for the invitation. Can you see my screen clearly?
Yes.
Okay. So I'm giving a quick survey about materials identification methods. You know, what we talk about here is, of course, identification followed by some action to sort. And we can think about that from many different areas of human activities, like diagnostics and treatment in medicine. The military have their fire on demand sort of. I would like to survey a bit here about what can we learn from other fields to generate some thoughts in this area. I'm with the physics department as senior professor. I am the founding director of the Lund Laser Center, now taken over by Claes-Göran Wahlström since a number of years. I also have a part-time job since about 10 years at South China Normal University in Guangzhou, southern China, where I helped build up a multidisciplinary center on applied laser spectroscopy. Okay. Automatic waste sorting is badly needed for many reasons. We heard about the economics, that's of course very important, and of course for eliminating depriving jobs. Just yesterday I saw in Aftonbladet, you know, these messages from India, where the lowest cost are doing this job all the time. Of course with extreme precision, because it's hard to beat the human eye, but we really don't want this activity to go on. So let's start with, say, methods to sort materials without prior characterization. We heard just about magnetic materials. Iron, stainless steel doesn't work, it's not magnetic. They are attractive, they can be separated by strong electromagnets. We don't need any sensors for that. Heterogeneous materials with different densities, they stratify, form layers, like we know wood floats on water, while most other materials sink. Cream floats on milk. In the mining area, it's a lot of techniques on enrichment of ores by flotation techniques using air streams and hydrophobic properties and so on, big industrial operations. And generally speaking, hydrophobic materials, you know, materials who don't like water, they can be separated from those who wet easily. It's about surface tension. So diagnostics for material characterizations and followed by some subsequent action. So what could that be? We heard about optical reflectance. Basically, it's spectral or color analysis. And that can be used with white light illumination from the sun or broadband light sources, followed by multispectral imaging. That means that we do the discrimination and sorting up about the different colors, about the different fingerprints from the atomic physics on the detection side. This is an expensive way to do it. But you can also do it on the illumination side, where we use these very effective LEDs, which are available at all colors, sequential illumination by them, use a black and white detector, and then sort things up on the illumination side instead. The other way to do that, not just use the spectral response, wavelengths, colors, of course, to use spatial or shape analysis, which is basically pattern recognition. Fluorescence is a very useful technique. UV illumination, and we get the fluorescence to longer wavelengths, papers, plastics, and so on, come out very easily that way. Laser-induced breakdown spectroscopy, or LIBS, we mentioned that before here, for metal identification. You could also think about sound analysis. You know, if you a church bell has a certain sound, if you tick on a broken cup, it's a completely different sound, like on an integer cup. And this is actually used, I was involved in that a bit in the melting industry to crack detection in big ingots. You can think about hardness analysis, how does it yield to some sharp thing, or you can use radio frequency response. Radar was mentioned here before. And you can think about technically susceptibility determination. It's different for different materials. And you can do matched illumination as used for identifying flying airplanes, for instance, by radar signatures. So let's think about similar problematics in other contexts outside the waste sorting area. face recognition, a much discussed thing. We have it on our mobile phones, of course, and we are afraid of it if it's used too much. Infrared imaging for feather detection at the airports, very common. Bottle inspection in the drink packaging industry, make sure that the bottles, maybe the reused bottles, are really clean. Clearing of tea, I've seen this in China. The tea, crude tea is falling down, imaged by a camera, and air nozzles are activated to blow out the big pieces and leaves and pieces of the stems and so on that. I come back to that later. Surveillance of automatic painting in sheet metal for the building industry, the construction sheets. I was a bit involved in a project at Finspång Aluminium on that, where they do this huge automatic painting, and you have to make sure that there is no problem there. There is a streak for hundreds of meters of sheet metal. Automatic clearing of weeds. Somebody discussed me about that, to make a machine in agriculture which goes along the crops and picks out the weeds but leaves what should be standing there. It's exactly the same problem as we discussed here today. Fruit fish quality control on a conveyor belt. I was approached from Norway looking into fish fillets, you know, to see whether it would be possible to see these nasty worms that sometimes are inside the flesh. Modified atmosphere control. I have a spin-off company, Gasporox here, and there's a project called the Safety Pack, which we were involved in. I mentioned something about that. Of course, the militaries have their automatic fire control, radar control, fire on demand, and so on. Pretty nasty activities. People have looked into and even demonstrated mosquito detection and pulse laser clearance. Identify the flying object and blow it out of the air with a powerful laser pulse. Not very economic, I tell you. Obstacle avoidance, vision impaired persons, the lawn movers that move around, we see them all around and doing the job that we normally do ourselves. And of course, the huge area of autonomous driving. It's all about object identification and doing action after the identification. And all of this more or less comes from the satellite remote sensing community, where these satellites, thousands of them now, are going around the globe, polar orbits mostly, and monitor what's going on the ground. Spectral, taking the spectral fingerprint, distinguish different things in that way, and textural, looking for the shapes. The military, they know what does a typical artillery battery looks like. You know, the structure, a robot launching ramp, and so on, a harbor, what does it look like? What does a tank look like? And automatically it's identified from space. And then you send out a drone or something, you know. So these things are very elaborate, and it all frequently in the spectral domain, looking at the color. Of course, the idea is that the material have different fingerprints. You can see a snow reflecting a lot in the visible regime. Crops are mostly reflecting in the green to the left there. They are like mirrors in the infrared region, damp earth and so on. And the satellites look into this and identify that. Like here, you can see from a satellite, different areas are automatically classified, and that's done by a push broom sensor. Typically, you image a line on the ground, and you get that line on a CCD detector in one direction, and the color in the other direction. And as you move forward, you image the whole area and make maps, like in Envisat here, which has 100 spectral bands to monitor that. It's exactly like waste sorting on a conveyor belt, if you like, but on a large scale. And this has been going on for decades, of course. So here's a picture of Sweden. We show all the pixels that fulfill the wood criterion, right? And it's wood everywhere. You can do temporal resolution, like in the lower right part, where you see the logging in Amazonas, how it changes over time. up to the left, you identify large numbers of different trees with very little signature shape differences, and still it can be done. So there's a huge community out there with enormous technology and heritage. I mentioned before also that instead of doing this analysis on the detection side to sort up the colors, you can instead illuminate the object at different colors, which is much cheaper. This is a system we made for Africa a lot, you know, with poor countries in Africa, especially together with a former student of mine, Mikkel Brydegård. And this is a microscope we developed for looking at malaria automatically. So what do? We illuminate the blood sphere with sharp light-emitting diodes, 20 nanometer each, sequentially, record it on a black and white camera, analyze that, and automatically pick out and show the pixels where the falciparum, the malaria, the parasites are sitting. Fluorescence. Well, fluorescence, that's this stuff you have on bills, for instance, or on your credit cards, or on your passport. If you shine on your passport with ultraviolet light, you see flaming colors in invisible things there, which identify things. And we worked a lot during the last 40 years with these techniques at close range, but also at large range, like with a LiDAR system, sending out UV pulses to monitor water quality at a distance, or hitting trees and getting the fluorescence spectrum. As you see, they're looking at the health of vegetation and so on. This we also do in China. This is a Chinese system that we built up in Guangzhou. And you can see here, of course, you can do it remotely. You know, like here you are in a field instead of in a conveyor belt where you do the waste sorting, but it's sort of similar. Or, of course, inside, we can do it in the lab. Natural thing to do with much simpler equipment. This can also be done by monitoring cultural heritage. For instance, you can scan the facades of Lund Cathedral. Here we've done that in 60 meters distance, and look for the fluorescence, look at different types of stones, classify that by multivariate analysis, different coatings, and so on. Quite useful and a bit revolutionary in this context. So this was all on large scale, from satellites or, you know, scanning facades. But of course, you can also do it in the small scale. The image line here can be across the conveyor belt in the sorting machine, and I think this is more or less what was illustrated just in the previous talk. And you illuminate and you sort up the different colors and do the fingerprint identification based on the colors. Here's a simple setup we made in China, handheld device where you point the laser beam down into the water. A lot of the water is polluted, of course, and you take the signal back to this, and you can classify from the Pearl River here different areas and sort it up into different types of waters, good water, bad water, and so on. Food monitoring, of course, extremely important. We have worked a lot with that in Lund here. There is a spin-off company, Parox, which is doing that quite successfully. Here's the question of monitoring the gas inside the packages without opening them, modified atmosphere to a longer shelf life and so on, and looking at the status. That's also done in China. We were part of a big European project where one system was installed at Santa Maria, who make the tortillas, you know, perfect things. Low oxygen, you can store it for months on the shelf if there is less than 0.1% oxygen inside. But are you sure that, you know, the sealing has done that? Well, that's done online here, and on the conveyor belt, the one which is not good is kicked off the belt. Okay, that's like the robots. You take it off, does it not fulfill your criteria, it's kicked off the belt. Fruits, most of fruit is wasted, as you know, it goes rotten. We looked at that quite a lot in Lund, a lot in China, in tropical fruits like that. They all look the same, more or less. Avocados, hopeless to say if they are ripe or not. We know that experience. But by fluorescence and reflectance analysis, we can do that, make a little device, as you see here, large like a cigarette package, to see the status and what is inside by spectroscopy. And of course, you can again monitor, think here about everything coming on the conveyor belt and doing the same thing, kick off the bad guy. We talked about LIBS, and the natural thing with LIBS, that is that you take a powerful laser pulse, you focus that into a small spot, you make a little spark there, it's like a little star, and we did that in the lab, but first in the world we also did it at large distance. Here in 60 meters distance, you see, we focus on material away, statue. We clean the statue by the laser spark, by scanning, and at the same time look at the spectrum, the fingerprint, where we can distinguish different materials with high resolution. And this is, of course, the situation which was discussed quite a lot about how to distinguish different metals. LIBS is the perfect way to do that. Here we have different, you see, copper, galvanized steel, brass, aluminum, iron. And here, even in 60 meters distance, followed by principal component analysis, we clearly split this up. And of course, the robot you saw before, as was already mentioned, in principle, by such a picking laser, doing these things, you could immediately see if it's copper, aluminum, or iron. The question is, of course, the economy in all this. Well, you know, in applied laser spectroscopy, you have more or less the same thinking in so many areas. Here is a concept we came up with regarding cardiovascular applications. More people die by cardiovascular problems than by cancer, as you know, and it's a question of cleaning the clogged arteries. And that can be done with laser pulses. But where are you? Are you shooting at the right place when you come in with your fiber? You can do that by spectral analysis first. And if the point where the fiber is standing is fulfilling the Planck criterion, then you fire the laser. Fire on demand, like the militaries. And then you go to the next point and so on and do the action. So detection and action, exactly like what we discuss here. So then we put our questionnaire, finally. How can automatic waste sorting be improved? I'm for sure no expert on this, but I just share different ideas from completely different areas, and you can find out possibly something that is applicable. We would like to reach the precision of the human eye. You remember the poor Indians sitting there living on the garbage dump with their children doing this job with extreme precision, but we don't like that. The precision of the human eye, but with machine endurance. You can do it by multispectral imaging, combining pattern recognition. Yes, a bottle is different from a shoe. A battery is different from a piece of ceramic from a bathroom. We can do that, and we can do the spectral identification, which has nothing to do with the shape, but the material, the atomic physics part of it. That's in reflectance, color measurement. And of course, we can do that in areas far outside the human eye. You know, as I said, vegetation which looks green, that is, you know, shining in the infrared region. And we heard here about the problem about black materials. They don't reflect. Yes, but in the infrared region, they are not black. They might look completely different. So use many different wavelength regions, then part of the problems can be solved. Fluorescence is a strong thing. Plastics fluoresces like mad, and paper fluoresces like mad. And you can have very easy ways of distinguish them using fluorescence techniques. Differentiation between metals, laser-induced breakdown spectroscopy, as we said, can do the job. Thinking about the falling tea I saw in China with a very primitive machine where the tea on a wide, broad level was falling down, and a camera looking into that, and when it saw a leaf coming or a piece of stem from the bush. It activated a nozzle and there was a puff of air and it flew out of that. Maybe we could do that here also. Normally we have our conveyor belts horizontal, but maybe we should let it fall instead. If you let it fall down, maybe you could blow off everything which is light, like paper and plastics, and the heavy thing falls down. When it falls down onto a metal plate, which is connected to a conveyor belt of steel, of course, in that case, you might listen to the sound and analyze by Fourier analysis. How was that? The ear is very clear, you know, if it's a stinging sound or if it's, and of course a computer can immediately distinguish a lot of things falling down. And depending on the sound, maybe there is a piston just pushing it off or letting it still there for later fluorescence analysis or lips analysis and so on. So these are just some food for thinking. I know nothing about waste sorting, but thank you very much.
Great applause, Sune. Thank you so much. Very interesting. Do we have any questions for Sune? Fredrik, you have one.
Yes, thank you very much, Sune. But I was wondering, is there any techniques that should not be combined? We talked about the illumination of the objects, but is there any techniques that interfere with each other? For instance, if you take libs and you have a very broad light for hyperspectral at the same time, do they interfere? Should they not be combined?
What can be said there, it's a question, you know, when you do libs, you must have a very short laser pulse. Of course, it's a 10 nanosecond pulse normally, and the emission is during a microsecond. So, of course, the detector can be gated, switch it on exactly at the right moment. It's typical laser radar. So you look at that, then you can do this in full daylight. If you look for fluorescence, you have to shadow off the area. But I saw your nice little house there was shadowed anyway. So fluorescence would be very easy to implement.
Okay. And just a follow-up question. Is there any technique that is not suitable or even dangerous? I know I've had this before, but if you have such a strong laser pulse, is there any way that any kind of material set on fire or be hazardous, or is there any combination of technology that should not be combined with any type of objects?
That's a very good question, of course. Talking about lasers, it's always the issue of laser safety, of course. We know below 400 nanometer, the eye is basically not transparent, so everything is relaxed by a factor of 1,000 or 10,000 there. And normally these illuminations are done in the ultraviolet region, what regards libs. But well, of course, if you make a laser spark, it's like a small ignition. So, you know, if you have flammable stuffs related to that, I think you should be careful. And of course, if you have isolated the metals before and are in an all metal environment, that nothing would happen there. But to fire on them before the metals are sorted out one way or the other, that might, of course, cause ignition. You can't eliminate that aspect.
Is the same with X-ray?
No, X-rays wouldn't do that. But of course, then you have to shield everything also. That can be done for sure. That's, you know, X-ray fluorescence is a very powerful technique, and you can see all the elements like there. It's similar to libs. So that is an option. On the other hand, you know, it might be a bit more tedious to do that here because libs is perfect remote. You just fire from above on that, and yeah, you know, it's, I think the implementation might be harder with X-rays. Otherwise, it works perfect.
Great, Sune. We have one more from, or you have a lot of questions, Chandramouli. We don't have that much time, but I'll take the first one at least. Would you like to say it yourself? I'll read it. How could we justify the cost of these technologies? Definitely, these are amazing technologies, but are they affordable?
Very good question. That's what it's all about, of course. You know, being a scientist and doing spectroscopy, it's a fantastic playing ground. And of course, not everything is practical. Like, you know, we have done a lot of mosquito monitoring. We never try to shoot them out of the air. That's not very economical, even if it's fully doable. And that's the same thing here. And, you know, I've been working a lot with industry. We have 3 spin-off companies who are on the stock market now, generated from our activities actually here in Lund. And of course, you always have to think about that, doing realistic things. That is it possible to do that? Actually, you always have that in your back head, actually, even if you are in science, in applied science. And well, you know, that is the question. When I heard these 10,000 objects sorted during 1 hour, what is the value of that? What is the value? It's important that you get the metals. We heard that. But if it's just garbage you are sorting, probably your machine is too expensive. It's a question of do the right pre-sorting, of course. Maybe by letting it fall, like I said. And you know, do something unconventional, put the conveyor belt vertical instead and use gravitation. I don't know. And then do the expensive thing later after pre-sorting.
Thank you, Professor.
Yeah, thank you. Yeah, great. I think we saved the other questions for afterwards. And Erik, would you take over?
Yes, I forgot to unmute. Yes, so and now for the final presentation. It's on the SenSoRe testbed for sensors and sorting for innovative recycling. PhD Jonas Peterson, research lead in material analysis and monitoring at Svedin. The floor is yours, Jonas.
Thank you. And right now the sun is shining in my face, finally. Let me start the presentation. So I think now you should be able to see my presentation slide.
Yeah, that works.
Great. So thank you for inviting me to speak here. It's a pleasure, and I think it's a good community to talk about this. And many things have already been said now, so I will try to be okay in time. So I'm invited to talk about both SenSoRe as the institute and SenSoRe as a project. But first, SenSoRe is a Swedish research institute based in Stockholm and Luleå. The name SenSoRe is new. It's only 1 year old, but the tradition goes back to almost 100 years ago when the first part was established, the Metallographiska Institutet, and then has been many names. Last was Svedin, Kimab, and now it's SenSoRe. So part of Svedin went into RISE, and we stayed as a independent research institute. So that's some background about that. And yes, the owners are to 20% RISE, but to 80% Swedish industry. Let's see, our business areas are in metallurgy, production technology, material development, and pilot plants. So it's mostly about metals in SenSoRe, but I will also talk about plastics. let's see. And the group where I'm active in is the group of analytical process monitoring, and we do research on techniques that can be used to monitor processes, and we do both the technical innovation of the equipment and also on the data analysis of it. So we work a lot with ultrasound, especially laser ultrasound, LIBS, laser-induced spectroscopy. So both in laser ultrasound and LIBS, we are very active, and I would say the leading actors especially in Sweden, but also in the world. We also use UV fluorescence, solution cathode glow discharge, and other optical techniques. I think I will try to be quick, and you can ask questions later instead. But so we use this for quality control in production and quality control for reuse of components, and also sorting of scrap, which is highly relevant here. So that's a quick introduction to SweRim and the activities. But now I will switch to the project SenSoRe, which is, sorry, I need to hide from the sun. SenSoRe stands for Sensors and Sorting for Innovative Recycling, and it's a project funded by Vinnova, started in 2017 and will continue until next year. And there are many actors involved here. It's the Research Institute Svedin and RISE, and also IVL and Svenska Miljöinstitutet. We have some sensor manufacturers, Cobalt and Opnova. We have some system manufacturers, Moberg, Elme Magnets, and Refined. And we have the recycler Stena Recycling, and also some production industry, Volvo and Hydro. So we cover a large span of the value chain here. So it's a good setting. So I will talk about the challenges of setting up this kind of test bed. So as you understand, it's very similar to what we heard about already from Fredrik, and but I think there are good opportunities for different kind of collaborations here, where maybe we focus more on the research of new sensors and their applications, and and so on. So let's see, some more introduction of SenSoRe. So it's still a project, and we're trying to get this sort of to be self-sustained in the future, but it's a challenge. We'll see. We're not sure how to get there still, but the offering is to strengthen the tech companies' possibilities and knowledge, and help the industry to improve recycling and quality control. And also, our idea is to offer not only the technical facilities, but also the access to the larger network of both recyclers and sensor manufacturers, as well as research institutes. And it's an open testbed, so everyone should be allowed to use it. And we see it as both a physical testbed, where we do have the conveyor and are able to test sensors, but also the the knowledge in recycling and the waste streams. Okay, so let's see. So we have in this project we have done some different test pilots to be able to show the strengths of this community. And so one of them is where we evaluated libs as a possibility for quality control different waste streams here at Stenberg Recycling in Halmstad. So so this is a typical way of how we work. So we go there for preparations and see how does the situation look like. Collect samples and prepare the instruments in lab at the physical facility of the test bed, and then test this at the field at the recycling facility, and also work on, of course, then the data analysis of this. So the main idea with the SenSoRe testbed is then to be able to bridge this gap between having a controlled environment where you can set up and develop the sensor as we have in the testbed, and then to first optimize it and then make sure that it can be applied in the production. And as has been said before, it's a big challenge with getting the material to train your sensor and to be able to validate your results with. So another pilot project has been on plastics, using libs for sorting black plastics, and also try to identify what do you call it, regulated material, or for example, flame retardants in plastics. See from the results here that it works okay, but it's not 100% perfect, and yeah, there are many challenges with libs that we can discuss later on. But also here we use both virgin material as for training the equipment, and then used real scrap samples that were collected at Skåne for testing of. Also very interesting project is use of magnetic sensors that to identify magnets in different equipment, and in hard drives here you see, and this research is mainly done by RISE. You have the contact here, Jakob Blomgren, who is also in the meeting, and also a more recent development, not mainly for we, but I still include it here since it's the technique as such is related. It's eddy current sensors for identifying different magnetic material, not only magnetic, but it can be used to separate different types of material that is magnetic. So sure, you can pick out magnetic materials with the magnet, but there's many different types of magnetic materials. So that's another example. We also have done some shorter studies going to different sites and see what the challenges are and how and sketch out how these things can be solved. So that's the type of shorter assignments that we think is shows usefulness of this SenSoRe consortium, SenSoRe Testbed. You see two examples here, also at Stena Recycling and one other at Volvo, where they do the cars in Umeå. Let's see. So finally, I will end with the challenges we see in this testbed. And so there's both technical and more, how to say, organizational challenges. A technical challenge is installing and implementing different equipment. And another one is obtaining large enough and characterized sample sets for training and validating methods. Also some organizational challenges is to get funding for research. I mean, it could be either national funding, or it could be also a challenge of having companies pay for these tasks. And also another challenge is to take the step between from when you have tested the sensor and try to actually get use of it to commercialize sensors. And also a final challenge I list here is to motivate to use new sorting techniques to get recyclers and producers to appreciate the benefits of using recycled waste and in better fractions rather than just using virgin materials. So I think this has to be the end of this presentation of SenSoRe and Svedin, and I see the time is running out, but I hope I'm still available for some questions. And I also want to mention the contact name for the SenSoRe project. That is Louise Hagberg, also in the meeting, and you see her contact there. So with that, thank you. Oops.
Thank you so much, Jonas. Do we have any questions for Jonas? I have one question, Jonas. If you should give one advice to Fredrik, who is one advice on one sensor to install now when you heard how his setup looks like.
Oh, that's a tricky question. Sure, we would like. I mean, we would like to collaborate on. We've already talked about this many years ago, even so we know each other from before. No, I don't think I can give one advice for one sensor. It has to depend a lot on the material, and there's some sensors are good for it's a point source and it's good for slower identification, and other sensors are good for larger streams.
Yeah, so, there is definitely some challenges with this.
Yeah, I can add that. I think the challenge here is to combine a sensor that Jonas has basically looking at one sensor at a time, and we do it like a combination, very roughly speaking. But the challenge is to combine this, and this was also a little bit of my questions to Sune previously.
And did you get an answer from Sune then?
Yes.
Good. So do we have any other questions or questions in general about this topic then? No, the time is actually running out. Erik, do you have any final thoughts?
No, I'd just like to thank everyone for attending, and as you say, the time is running out. We will of course stay here, and we would love if there is an open discussion. But for now, thank you to everyone who has, well, especially to you who have presented, and to everyone who's been active and asking questions.
Yep, and don't hesitate to contact us if you want to engage in anything, or as I said before, if you need a contact to someone who has attended, we will try to help you with that. So for those of you who need to leave, thank you for today. And for those of you who wants to stay and chat, please do so.